Hey you guys, this is Mr. Millings, and in this video we are going to learn how to determine the wavelength of a wave. It says right here that the formula below will allow you to determine the wavelength, frequency, or speed of any transverse wave. So let's suppose we have a transverse wave here, and we learned the difference between transverse waves versus longitudinal waves in an earlier video. And what we want to do is we want to determine the wavelength of this wave, or lambda, which is the Greek letter of the alphabet that is used to symbolize the wavelength of a wave. Well, if we want to figure out the wavelength of this wave, we can use the wavelength formula that we see right here. Lambda equals V over F, where lambda is the wavelength of that wave, typically measured in meters. V is going to be the wave speed or velocity of that wave, usually measured in meters per second. And F here is going to be the frequency of the wave, typically measured in hertz, or s to the minus 1 power. And so we can use this formula here to not only figure out the wavelength of the wave, we can also use this formula to determine the wave speed of the wave and the frequency of the wave. So let's go ahead and use this formula first to learn how to determine the wavelength of a wave. In this example, it says to calculate the wavelength of a wave traveling 3.25 times 10 to the second meters per second through a medium with a frequency of 6.61 times 10 to the 6 hertz. So it looks like we have a wave here. And what we know about this wave is that this wave has a frequency that equals 6.61 times 10 to the 6th hertz. We also know that this wave is traveling, let's say in this direction here, with a speed or velocity of 3.25 times 10 to the second meters per second. We have to determine the wavelength. So if we want to figure out the wavelength, it's simple. We can use this formula right here. Wavelength equals wave speed or velocity divided by the frequencies. So let's go ahead and solve this problem here. The wavelength is going to equal the velocity divided by the wave's frequency. So in this problem here, we see that the velocity of this wave is 3.25 times 10 to the second meters per second. And we see that the frequency of this wave is going to be 6.61 times 10 to the 6th hertz. And a fancy way of writing hertz is s to the negative 1 power. That just means that this unit seconds is in the denominator, and that now allows us to cancel out these two units right here. And so when we put this in our calculator, we're going to end up with 4.92 times 10 to the negative 5th meters, it looks like. So we just figured out the wavelength of this wave. The wavelength is going to be 4.92 times 10 to the negative 5th meters. So that is how we're going to use this formula right here to solve for the wavelength of a wave when we're given the wave speed or velocity and its frequency. So if you like what you see, go ahead and click that little bomb in the bottom right hand corner, and that will subscribe you to my channel. And feel free to leave any comments or questions in the comment section down below. And I really hope you guys found this helpful.